probability. The first question, two dice are tossed. The sum S of the two dice is calculated. We're asked, find the probability that S is less than 5. And then in part B, it is known that a 2 appears on at least one of the dice. We need to find the probability that S is less than 5. Very good. Now our solution, right, initially 2 dice are tossed. So the possible results, we write them down systematically. Now we consider a first dice and a second dice. So let's say we had a 1, then a 1. Or the first one could be a 1 and the second one 2. Or it could be a 1 and a 3. Or a 1 and a 4. Or we could get a 1 and a 5. Or a 1 and a 6. We'd have to stop there because we couldn't get a 1 and a 7, could we? Because, okay, a dice doesn't go up to 7. So that's all the possible ways that the first one could be a 1. Then we move over and say, well, let's say the first one was 2. You could have a 2-1, or a 2-2, or a 2-3, a 2-4, a 2-5, or a 2-6. Again, we've exhausted all the possibilities there of the first one being a 2. We could think of the same way for a 3, and the same way for the first one being 4, or a 5, or getting a 6 first. So it's important when you're doing questions involving throwing a couple of dice that you write down those lists, because it's a fairly simple way of doing it. You'll notice there are 36 results altogether, and from once you've done that list you should be able to work out, pretty much any sort of question they'll throw at you. Part A. Find the probability that S is less than 5. So the probability that S is less than 5, well, I've highlighted there, all those there have a sum of less than 5, that are less than 5. Everything else you'll see is 5 or greater. So it happens 6 times. So the chance or probability is 6 out of 36, which breaks down to 1/6. Okay, it's always a good idea to simplify your final answer. Part B. It is known that a 2 appears on at least one of the dice. Find the probability that S is less than 5. Now if you throw the dice and you're certain that a 2 appears on it, then if a 2 appears on at least one dice, then we're restricted to those possibilities. Okay, those possibilities highlighted are the occasions where there is a 2 appearing on at least one of the dice. So now our results then are out of 1-2, a 2-1, a 2-2, a 2-3, etc., all the way up to finally a 6-2. So now let's see what the question's saying. There's 11 results there. We need to find the probability that S is now less than 5. Well, if we consider that happens 3 times there out of those 11 results, so the probability we'd write would be 3 out of 11, which is 3/11ths. Next question. Students playing at least one of the sports, cricket and touch football, attend a meeting. Now of the 30 students present, 18 play cricket and 20 play football. We're asked these 3 questions. What is the probability that a randomly chosen student plays cricket? 2 randomly chosen students both play cricket, and finally a randomly chosen student plays both sports. Well, these sorts of questions, when you're talking about 2 groups, we'll draw a circle representing the cricketers, and we'll draw another circle representing the touch football players. And we've deliberately chosen those circles to overlap. Let's see why. 18 play cricket and 20 play football. So 18 plus 20 is equal to 38 students. But we only have 30 students. So we're trying to fit 38 students into 30. That means there therefore 8 overlap. So in that overlapping section there are 8 students. In other words, 8 students both play cricket and touch football. So that's what that means. Very good. Now let's try to fill in the rest of what's called this Venn diagram. We're told that 18 play cricket. So in our cricket circle we need 18. Well, we've already got 8 in there, so we need another 10. So together, yes, 18 are in that cricket circle. Now 20 play football. 20 play the touch football. Looking at that circle, we need another 12 to make 8 and 12 together make the 20 playing touch football. Very good. Let's start answering the questions. Part A. What's the probability that a randomly chosen student plays cricket? Well, probability of a cricketer, well, there's 18 there, so 18 chances out of 30. Breaks down to being 3/5. Part B. Probability that two randomly chosen students both play cricket. So in other words, we're having the probability of a cricketer then a cricketer. Well, let's look at the first. So the first person, the first chance that they're a cricketer would be 18 over 30. We've already worked that out. But what about the second person to be a cricketer? Well, once we've actually chosen one cricketer, then there's only 17 cricketers left. Out of how many students? Out of 29. So the chance that second one's a cricketer also 17 over 29. And remember, when you are following one probability by another, when you require one event to be followed by another, we're going to multiply the individual probabilities. Very good. That works out to be 51 over 145. Part C. Final question. Find the probability that a randomly chosen student plays both sports. Well, from our diagram, the probability that a cricketer and of a player being both a cricketer and a touch footballer, there it happens 8 times. 8 times out of the 30 students. So there's our probability, 8 over 30. Again, this will break down, this time to be 4/15.